Hi, this is Peter with CalcBook, and today we're going to be looking at another timber connection design, specifically looking at a toe-nailed joist connection. So just a quick recap, right? We are using the National Design Specification, also known as the NDS. We have two books that we use, the NDS spec, which kind of outlines our design procedures, our capacity equation, adjustment factors, whether we're in lateral or within withdrawal. And then we're focusing on our dowel type fasteners, so bolts, lag screws, wood screws, nails and spikes, that sort of thing. Then we also have the NDS supplement, which is more for reference design values for our wood members, so our different properties that we might need to be using. For connections, we don't use this quite as much, but sometimes we still need to reference it, so it's good to have it available. So for today's video, right, we're going to be looking at lateral loading, and we're going to be looking at lateral loading for nails and spikes. And the only sort of different thing that we're going to be looking at here is that we are going to be having a toenail connection. So we'll look at that in a second here, but we just remember that we need to include this toenail reduction factor, which CalcBook will do automatically. We just need to make sure to check the box that this is a toenail connection. So if we take a look at our problem statement for today, right, we want to verify this toenail connection. We've got basically a joist connected to a beam. Both are Douglas fir larch members. We're going to be using common box nails, and we will determine the size needed to support the load, but we're going to be using 6 total, so 3 on each side. We have dry fabrication condition, dry service condition. We'll go ahead and use ASD loading, and as we mentioned before, right, this is a toenail connection. Our joist reaction force is going to be a dead load of 225 pounds and a live load of 375 pounds. So let's go ahead and open up a CalcBook and we'll get started on the design. All right, I've got CalcBook open now, so go ahead and click into our NDS 2018. Go ahead and click on our connection design, and then we're going to be doing a group of dowel type fasteners for lateral load. You could do, in this particular case, a single dowel, since the group effect does not affect small diameter dowels like nails, but this way it'll just automatically add up all the capacities of each fastener, give us the total capacity of the connection. So we'll go ahead and click on this one. And our dowel type, right, we said is a common nail. Our size we did not define, so we'll start with an 8-penny, and then we will upsize from there and see if we need additional capacity. We are not using this in diaphragm construction, but this is a toenail connection, so we want to make sure we check that box. We decided we had 2 rows, essentially, right, because we have nails on each side, and then we have 3 total fasteners per side, so that's going to give us a total of 6 fasteners. Our main member, right, which is the beam that's the joist is connected to, is a wood member. We said it's a Douglas fir larch. And we do need to actually update this load angle here. So because the load is perpendicular to the grain, right, we need to set this to 90 degrees. And then our thickness of this is going to be, we said it's a, I don't think we said it's a 4x8, but it is a 4x8, so we're going to go ahead and give that 3.5 inches. And then our side member, which is our joist, right, is also Douglas fir larch. And it is going to have also a load direction of 90 degrees because it's going to be loaded perpendicular to the direction of the grain. And then our side member thickness, this is a 2x, so it's going to be 1.5 inches. We do not have an end grain condition. We have dry service, dry fabrication, no temperature issues, and we are going to be using dead plus live, so we can go ahead and use that 0.8 for live from occupancy. So we'll leave that set to 0.8. Actually, the last thing we need to do is change this over to ASD, excuse me here, so we will not have the time effect factor. We will have our load duration factor, which we can then update for occupancy live load, right, is going to be 1.0, so we will leave that as a 1.0 for CD. Okay, so now we need to enter in our loads. Our dead load is going to be 225 pounds, we said, and our live load is going to be 375 pounds. And we can see we are over by about 25%, 1.24 there. So before we dive into that, let's go ahead and take a look at our calculations. So we've got our demand calculation, right? We've got just our dead plus live load case 2, or excuse me, load combination 2. Then we can dig into our calculations here. So we have some preliminary stuff we need to check, right? The taper of our tip, because we want to reduce that from our bearing length. And then we calculate our bearing length. And then we will calculate our main member bearing strength, right, which is going to be based on the specific gravity of the member. And same with the side member. These are the same because we have the same specific gravity. We calculate our ratio values. Those go into our K values, right, K1, K2, and K3. For a small diameter fastener, right, our KD is 2.2. It's the same for all of them. And that goes into our RD, which just equals K sub D. We check all of our nominal yield modes, right? So we have our different lateral modes that we need to check for the fastener. Then we go through our adjustment factors, right? We have our wet service factors and stuff are all going to be 1. Our group action factor, like I said there, does not contribute for small diameter fasteners, so those are both 1 for the group and the geometry factor. Our end grain, this is not end grain, so that's 1. The only thing we apply here is our toenail factor of a 0.83. Then we can calculate our connection capacity, right? And we just multiply that by our total number of bolts here, or excuse me, total number of nails. We get our DC of 1.24. So let's go ahead and go back to our capacity here, and we can up this to maybe a 12 penny nail and see if that updates the calculation. So we're 3% over, so maybe a 16 penny. And that should get us below. So that is a toenail joist connection in CalcBook. We hope you enjoyed the video. If you have questions or suggestions for other videos, please let us know in the comments below, and we'll see you next time.